Hi everybody, this is the second video of how to calculate the surface area and volume of a three-dimensional object, specifically a rectangular prism or a square prism. In this example, however, compared to my previous video, we are dealing with binomials. And although that doesn't really change the principle of how to get volume and surface area, it changes the way that we have to do the calculations. So with that said, let's go ahead and jump right in. So in getting the surface area, we have to keep in mind that we want to get the area of all the surfaces combined. And for the volume, we only want to incorporate the length, width, and the height. So being that the volume is easier, we're going to start with that. So I want to first label my length, width, and height, though technically it really doesn't matter because you're just going to multiply everything anyway. So this could be called the length. This could be called the width, and this could be called the height of that prism, how tall it is. And so all we have to do is take those binomials and replace them into this formula that I have right here, which is volume is equal to length multiplied by width multiplied by height. So I'm going to raise this up a little, and we can go ahead and do that right now. So plugging in what I know that my length is p plus 4, so this will be p plus 4, and this will multiply to my width, which is 3p minus 2, which will then multiply to my height, which is p plus 1. Now, the best way to multiply binomials when you have more than two of them is to just do it two at a time, and that way you'll be done in no time. So going ahead and multiplying p plus 4 times 3p minus 2, there are three different methods. I'm going to incorporate what is sometimes called the distributive method or the FOIL method. So it goes like this. I take the first term and I multiply to the first term of the other. Then I repeat, but with the second term of the other. So doing that, what I have so far is p times 3p is 3p to the second power, or 3p squared. P times negative 2 is negative 2p. Then I go ahead and repeat the same process, but with the 4. So 4 times 3p would be plus 12p. And then 4 times negative 2 would be negative 8. Okay, now I still have to multiply all of this with my p plus 1, so I can't forget that. But for the time being, I will not do that. Okay, so I'll leave this in parentheses, and I'll bring this down, p plus 1. But I still have to simplify what's inside this parentheses because I have like terms right there. So what I get right now is I have 3p squared. This will be plus 10p and then minus 8. Now this will multiply with p plus 1. Now the way to multiply a trinomial to a binomial is pretty much the same way that you multiply binomial to binomial. You can use three methods like I mentioned again, the box method, stacking method. The distributive method, also known as the FOIL method, would work just fine here as well. So I'll go ahead and do it that way since that's how I started. So this would be p multiplied with 3p to the second power. So this is going to raise that power by 1, leaving me with 3p to the third power. Then I multiply p with 10p, and I would get plus 10p to the second power. Then I multiply the p with negative 8, and what I would get is negative 8p. Now, then I repeat the same process, but this time using the plus 1. So plus 1, I can multiply any way I want. So I'll just go ahead and do that with 1 times negative 8. That would be negative 8. 1 times 10p would be 10p. 1 times 3p to the second power would be 3p to the second power. Now to organize this better, what I recommend is that you draw pathways from one like term to another so that you know what's supposed to connect with what. So doing that, I'll use a different color here. So doing that, I know that this will connect with this and combine. And I also know that this will connect with this and combine there. Now the ones that don't have another term to combine with is the constant right over here, which is a -8. Also, this 3p to the third power has no other term with which to combine. So putting everything together, what I have is 3p to the third power then I have, sorry about that, that was my phone. Then I have to combine my powers of 2, so this would be 10p squared plus 3p squared is 13p squared. Then I have to combine my p's together, so this would be -8p plus 10p, that's 2p. And finally my constant goes at the end, and that would be my volume. So there's definitely a lot more involved this time when we did the volume compared to what we did the last time we had to calculate the volume. Last time we did the volume, it was just 3 numbers multiplied together. I can even take you there to show you. 3 numbers multiplied together, boom, we're done. But over here, it's not quite that simple. So we have to be careful with how we multiply our binomials and trinomials. So that's the volume. Now surface area requires that I calculate the area of all the surfaces. Now to do this, I have to, again, work carefully, because what I want to do is I want to first get the area of each visible surface and then double it, because there are 2 of a kind. So the area of this side would be p plus 4 times p plus 1. The area of this side would be 3p minus 2 times, now the height is p plus 1, because this height is p plus 1, this height is also p plus 1. Okay, so again, this is p plus 1, that's a height, and therefore this height is also p plus 1. So I'm going to multiply the width times the height, so times p plus 1. Okay, it's always 2 dimensions that you have to multiply, a length and a width, or a width and a height, or a length and a height, etc. Okay. Now the area of the top will be of this. This will be, again, it seems like nothing is labeled, but actually you have the length all along this, that's the length, and if you look at the bottom, this is called p plus 4. So therefore this is also p plus 4. This side here would be 3p minus 2, because this side is 3p minus 2. Okay, so I'm using the width and I'm using the length here. So width 3p minus 2, length p plus 4. So 3p minus 2 times p plus 4, that's my area of the top surface. Now I need to double everything, but first I need to go ahead and multiply these things together. So what I have so far is the following. I have, for the surface area, I have 2 of these. This is the top, p plus 4, okay, that's a top. I'm going to add that to 2 times the side, this side over here, this left side. So it's 2 of these, 3p minus 2, multiplied with p plus 1. Then I have to do this side here. I have 2 of these, one at the front, one at the back. So it's going to be plus 2 of those. So that's p plus 4 times p plus 1. Now this looks terribly long, and it is, but we can break this down if we just work in steps. Okay, so the first step I need to do is I need to multiply these binomials together, get a trinomial from that, and then multiply the trinomials by 2, and then just add everything together at the end. So it's going to get a little bigger before it shrinks down. So here we go. This will be 2 times. Now multiplying these binomials will give me 3p to the second power. This will be 12p minus 2p is 10p, and then minus 8. This will be 2 times 3p to the second power. 3p times 1 is 3p, minus 2p is just 1p, and then minus 2. Plus 2 times, this will be p squared plus 5p plus 4. Now, when I multiply the 2 inside, I'm going to get something that I can finally combine all together. So multiplying the 2 inside, okay, distributing that 2, 2, 3. What I get is the following. I get 6p to the second power plus 20p minus 16. Over here, 6p to the second power plus 2p minus 4. Over here, 2p to the second power plus 10p plus 8. Now I said this would seem to stretch and expand before it shrinks, but it's about to shrink because we're going to combine all of our like terms together. And our like terms are here. And I'll do it differently this time. So because we have so many terms, I'll use shapes to designate what goes with what. So powers of 2, and technically I'm going to include that plus sign in there. Okay, so powers of 2 go together. Powers of 1 go together, so that would be this one, and this one, and this one. And then constants, they go together. So that would be this one, and this one. Okay, those are all the constants. So doing the leading terms first, the highest powers, what I get from that is 6p squared plus 6p squared is 12p squared plus 2p squared is 14p squared. So 14p squared. 20p plus 2p is 22 plus 10 is 32p. Negative 16 minus 4 is negative 20. Negative 20 plus 8 is negative 12. And that is our surface area. So I hope this video helped you out. There's definitely a lot more involved in this example than there was in my previous one. But if you're careful with your steps and you just keep track of things, you'll be just fine. Thanks for taking the time to watch. Hope to see you again next time. Bye-bye.